The autoregressive distributed lag (ARDL) model is a powerhouse in econometrics, especially when you're dealing with variables that don't move at the same speed or have different underlying rhythms, integration orders. Think of it as a way to model how a variable depends not just on its own past, but also on the current and past values of other explanatory variables. 1. The intuition, memory and echoes. Imagine you are trying to predict consumer spending. Autoregressive, AR, your spending today is likely influenced by how you spent yesterday, habits. Distributed lag, DL, your spending is also influenced by your income today, but perhaps also by a big bonus you received 3 months ago that you're still gradually spending. The ARDL model captures both the memory of the dependent variable and the echoes of the independent variables over time. 2. The mathematical structure. A standard ARDL, P, Q, model looks like this, where y_t, dependent variable at time t, gamma_I, coefficients for the lag-dependent variable, the AR part. Beta_j, coefficients for the current and lagged explanatory variables, the DL part. P and Q, the number of lags, how far back into the past we look. 3. Adding dummy variables. Dummy variables, 0 or 1, are used to capture qualitative shifts or structural breaks. In an ARDL context, they act as intercept shifters or slope shifters. The shock scenario. Suppose you are modeling GDP growth, but your dataset includes the year 2020, the COVID-19 pandemic. If you don't account for that sudden, massive drop, your model's parameters will be biased because it's trying to find a normal relationship in an abnormal year. The equation with the dummy, d_t. If d_t equals 1 during the pandemic and 0 otherwise, the coefficient alpha tells you exactly how much the average growth shifted during that specific period, independent of your other variables. 4. Why use ARDL? The secret sauce. The ARDL model is famous for a few specific reasons. Mixed integration. Unlike VECM or Johansson cointegration, ARDL works if your variables are a mix of I, 0, stationary, and I, 1, stationary after first difference. Note, it strictly cannot be used if any variable is I, 2. Small samples. It is much more robust and reliable when you don't have decades of data. Long run versus short run. Through a bound test, you can transform the ARDL into an error correction model, ECM. This allows you to see short run dynamics, immediate reactions to changes. Long run equilibrium, where the relationship eventually settles. Speed of adjustment. How fast the system returns to normal after a shock. Summary table. Feature. Description. Flexibility. Can handle different lag lengths for different variables. Simplicity. Can be estimated using simple ordinary least squares, OLS. Dummies. Effectively filters out noise from policy changes or crises. Requirement. All variables must be I, 0 or I, 1.